Hello, this is Mr. Win, and this video is over solving 3x3 systems using substitution. So a 3x3 system means there's three equations with three unknown variables. The solution to the system is the point or points of intersection. There could be no solution, one solution, or infinitely many solutions. Because we have three numbers now, it's called an ordered triple instead of an ordered pair. Graphing 3D by hand is unreasonable, so we're going to stick with algebraic methods. Substitution is still a valid method that works the same way as before. We're going to have three equations with three variables. You can solve for one and plug in to make two equations, two variables, which then you solve for another variable and plug in, which make one equation, one variable. You solve that and then you plug in going backwards. If all variables disappear, you know the false statement, that means no solution. If all variables disappear and you know the true statement, that means infinite solutions. These problems are very long, so it's recommended that you be organized and label your equations. Here's a triple system. I'm going to label them 1, 2, and 3. I'm going to solve one of them for a variable. I'm going to solve the third equation for A. It's a good choice because it's coefficient 1. You can also for B here, C here, C here, even A or B on the first equation. For my third equation, to get A by itself, I'm going to 2B and the C. To get A equals negative 2B minus C minus 5. I'll plug this A value into the A for equation 1 and equation 2. So I do equation 1 first. Here's equation 1. I put A in green. I'm going to just plug in this negative 2B minus C minus 5. Be careful, this negative outside, there's a negative 1 that I have to distribute. So I'm going to distribute. Then I'm going to combine like terms. Then I move this 5 over by subtracting. And here's what I'm going to call equation number 4. This equation has two variables, B and C, and no A. I'm going to do the same thing for equation 2. I'm replace this A with negative 2B minus C minus 5. I put in green. So I'm going to plug in. Then I'm going to distribute the 3, combine like terms, and then move the 15. Here's my fifth equation. It has B and C, no A. So I'm going to do the substitution for 4 and 5. I pick either one, doesn't matter. I'm solving equation 4 for B. So I move this 2C over by adding it. Now I know what B is. I'm going to plug this equation B into equation 5 right here. So let me rewrite equation 5. B is now in green. I'm going to replace B with 2C minus 14. I'm going to distribute negative 5. Combine like terms. Move the 70 over by subtracting. And here's what I call equation 6. Negative 12C equals negative 60. So we have one equation, one variable. One subdivision divided both sides by negative 12. You get C equals 5. Once you have the first value, you're going to plug in going backwards. Now if C would find B using either equation 4 or 5, it doesn't matter. I'll use equation 4. So here's the equation 4. I'm going to replace the C, which I put in green, with its value of 5. I'm going to multiply and then combine like terms to get B equals negative 4. Now I know B and C, I need to find A by plugging these two values into one of the first three equations. It doesn't matter which one you use. I'll use the third one. So here's the third equation. B and C are in green because I'm going to replace them with negative 4 and 5. Then I'm going to multiply, then combine like terms, then I'll move the 3 over by adding. You get A equals negative 2. Name us for these three numbers as an ordered triple in alphabetical order. So the solution is negative 2, negative 4, 5. That's it for the video. Thanks for watching. If you have any questions, ask your teacher. Thanks. Bye.